Hi dear students, welcome back to mathematics online classes. In our previous classes, in our previous videos, we people have completed that what is the integrals or integration. Integration, here two types, indefinite integral, definite integral. The several things you people have studied in the previous videos. Now, what are the applications are there for the integrals? That is application of integrals, very important chapter. How to use these integrals as applications? For example, I just consider the one curve. Let y is equal to f of x be a curve. Y is equal to f of x be a curve. Suppose the curve is in this manner. I am just generally taking y is equal to f of x be a curve. This curve is defined on a closed interval a comma b. This curve is defined on a closed interval a comma b. That means domain of this function is a to b. That is defined from closed interval a to b is that. This is x is equal to a and this is x is equal to b. In this case, I need to find the area of the curve. Area under the curve we need to find. What is the area bounded by this curve we are required to find? So from the a to b, this curve is in this manner. Below this curve, what is the area is there? Why is this required to find this total area? To find this total area, we just use the integrals. Using the integrals, we can easily find. For example, why I am just using integral means, for example, if they ask to find the area of a triangle, there are several things out there to find the area of the triangle. It is whether they given a base and height, whether they are given a side length, whether they are given coordinates. Different cases are there. All conditions we can use it and we can easily find. In determinant also you just take on that. By using the determinant also we can find the area of the triangle. Particular shape is that we can find. Area of the square we can find. Area of the rectangle we can find. Okay, several things are there. This is particular shapes are there. But come to here. This is a curve. It do not have a particular shape. So in such cases, we have to use the integrals. With the help of the integrals, we can easily find the area under the curve. How to find this one? So this is the defined on a closed interval. A comma b is that. So a comma b is considered from a to b. Now I just going to consider our vertical strips. I'm just going to consider the vertical strip. These are this whole portion. I am just dividing into small portions. Vertical strips I am just going to find. Actually, this concept is that in integrals, that is limit of a sum. Limit of a sum is that due to this pandemic situation, COVID, this chapter or this concept has been removed for this academic year. So that is instead of discussing here, I am just going to discuss here. So I am just directly give the formula. You just know that, or else I am not giving. Anyway, let's have the look on that one. So what is that one? Means already you know the definite integral. What is the definite integral? A to b, integral of a to b f of x into dx. Integral of a to b f of x into dx. This we can write it as integral of limit of as n tending to infinity. So limit b minus a into n tending to limit n tending to infinity f of a plus f of b plus or f of a plus 1 f of a plus h. This like formula is that. Instead of discussing this one, we just say that definite integral means area under the curve. Definite integral means area under the curve from the limit a to b. So here area under the curve. To get this one, I just made the small strips. Rectangle will get it. Strips means here it is a rectangle. A small portion is there. This is not a rectangle. This is how is that. But here the small portion, that means curve is there. This curve we are going to remove that one and we are going to add the same portion. Then we will get this expression. Anyway, so leave it. Nothing to worry. Now I just make the small strips. Then I am just going to name this strip as dx. The length, the width of this strip is dx. How many are there? There are infinite number of strips are there. So that area under this curve is equal to directly defined by area under the curve f of x integral from where to where, from a to b, from a to b. F of x is function width into dx. What is the dx? Length into breadth. What is the breadth? Y. What is the area of the rectangle? Area of the rectangle is length into breadth. X into y, or length into breadth is in the same definition only. I just consider the strips are there. The small curved portion, neglect the small curved portion. Small strips are there. Dx means small change in the x definition of the derivative. Dx is nothing but a small change in the x in that manner. So neglecting that small portion, so we'll get the length into breadth. What is the length? Y is the length. Y is nothing but f of x. And dx is nothing but breadth. Dx, we get the required area under the curve. I got that? How to find the area under the curve in this manner. What is how to generate this area of the rectangle? So length into breadth. Here also I just got the strips considering as a rectangle, but here small curved portion is there. That curved portion is neglected. That's why we get the limit of the sum definition. That's why become the limit of a sum definition. Okay, nothing to worry. You just remember this much. We get the thing. Okay, next here y is nothing but height, dx is nothing but width. So x is equal to a. This will get the f of a. This will get the f of b. So x is equal to a and x is equal to b. Next, one more orientation is that. Suppose the curve is in this manner. Suppose the curve is in this manner. In this case, here a curve is given as y is equal to f of x. If the given curve is equal to in terms of f of y, curve is equal to in terms of f of y, given curve, let x is equal to f of y. Here y in terms of x, here x in terms of y. On depend on a closed interval c comma d I just take different interval I just take c comma d. So here y in terms of x, so that x is equal to a, x is equal to b. X in terms of y, therefore y is equal to c, y is equal to d. So this curve is defined from c to d. So here it is y is equal to c and y is equal to d. Interval is there a comma b, c comma d, c is less than d. Okay. We need to find the area under the curve. This area we need to find. Once again the same thing. Consider a small strips. Consider a small strip. What is the width of the strip? Width is nothing but this value minus of this value. This value minus of this value. What we get? In this case, we get the width is dy because height is the y. Width is nothing but x, height y is the dy is the. So what is the area under the curve? Area under the curve integral from lower limit to upper limit, lower limit to upper limit, c to d. Then here f of x into dx is just written, or y into dx. Here what we have at x into dy, length into breadth. Length is what? X. This is the length. Length is nothing but x axis we have to consider. This is the x is the length, x into height, length into breadth, dy, or else we can write integral of c to d. In place of x, we can write as f of y into dy. F of y into dy. This is how we have to find the area under the given not defined curve or not a particular shaped curve. In this manner, we have to find the area under the curve. So these are the two orientations. One more orientation is that is nothing but suppose I just take it as a node. Suppose the curve is present below the x-axis. Suppose the curve is present below the x-axis. Y is equal to f of x. Here it is in the first quadrant. Here it is in the first quadrant. But suppose the curve is present in the fourth quadrant. That means x is equal to a and x is equal to b. Y is equal to f of x. F of x is a negative value or y is a negative value. In that case, whenever you are finding the area, it is sufficient to take the modulus of a to b y into dx. Modulus of a to b, integral of a to b y into dx. Because area is always measured in the positive quantity, so that reason we have to take it as a, if you got the negative value, we have to consider as a positive. Because definite integral, if people have solved the several problems in the definite integral, the after applying the limits, upper limit, lower limit, then the difference we have to take. After simplification, a real number will come. That real number might be positive or negative. Real number is that positive or negative quantity. If we got the negative quantity, we have to consider it as a positive quantity. 1, 2 and 3. One more orientation is that. Just pause the video, just note down these graphs and definitions. This is definition for this and this is the definition for this orientation. Now, one more is that. One more orientation means y is equal to f of x defined on a closed interval a comma b. For example, sin x if you consider, what happens? Area under the curve from a to b. If they given y is equal to f of x, area under the curve y is equal to sin x on the interval 0, 2 pi. End points are included 0, 2 pi. This is exactly the required graph. Sine graph will continue, no problem. But limit is that 0 to 2 pi. In that case, I will find same thing. I just split this interval due to the properties of the definite integral. What is the properties of the definite integral? Integral from a to b f of x into dx can be split it as integral of a to c. C is belongs to this interval f of x into dx plus integral of c to d f of x into dx. I will split. I know that this property, using this property as a split 0 to pi and pi to 2 pi. Area is equal to, this size is called as a1, this size is called as a2. The required total area is equal to, this is the total area is equal, required total area is equal to a1 plus a2. What is the a1? Integral from 0 to pi. In the same manner, as is write generalized problem, c belong to the closed interval a comma b. Integral of, or else first of all write integral of 0 to pi y into dx. Height is dx is a plus integral pi to 2 pi to 2 pi y into dx. What is y value? Sin x value. Replace it, simplify, you get the required area. That one we can write in generally, that is area is equal to integral from a to c. C is the any point in the given interval y into dx plus integral of c to d y into dx. Same function is that. Here also the same curve. Y is equal to sin x. Same curve is that y. Replace it, but interval is different. Okay. Here negative is that. It will come the negative value. We have to consider it as a positive value. Which one it comes a negative value? Positive. If area comes a negative, consider as a positive. If a2 comes a negative, consider as a positive. However, which area comes a negative value, consider it as a positive value, because of area is always measured in the positive quantity. Okay, I hope you will have understood the definitions and meaning. Now, directly go to the examples. How to find the area of the particular given curve. Okay, find the area under the curve, or find the area. Find the area enclosed. Find the area enclosed by the curve. X square plus y square is equal to a square. X square plus y square is equal to b square. So, do you know that any particular name of the curve? X square plus y square is equal to a square is the name of the particular curve. Curve is given. What is the particular name? Is that, do you know the particular shape of the curve? Yes, it is a circle. It is the circle having the center is at the origin. Radius is equal to a. Generally, we know that x square plus y square is equal to r square. Center is at the origin and radius is r into r value is a. So, while solving the problems of application of integrals or in this areas, geometry problems particularly, you must and should get the basic or rough diagram. If you got the rough diagram, you can easily solve the problem. So, what is the rough diagram of this one? Circle is given. this is the circle is that. What is the general equation of the circle? X square plus y square is equal to a square. Center is at the origin. Then radius of the circle is equal to a unit. Here it is the a is that. What is the coordinate of this one? A comma 0. This is x is equal to 0 and x is equal to a, which is what? We need to find the area enclosed by the curve. Total area enclosed by the curve. Previously found out that area only in the first quadrant, area in this manner, or area first and the fourth quadrant value. Here all the four quadrant is there. So is it divide? Whatever the area is there, this area, the same area is there in the second quadrant. Similarly, the same area is present in the third quadrant. Same area is present in the fourth quadrant. So this area, I just name it as area A. 4 times of the area is equal to the required area of the limit. Required area is equal to 4 times of this area. Will you get it? I got my point. Total area enclosed by the curve, total area we need to find. So that required total area is equal to 4 times of this area. Because if you know this much, we can easily find the. If you have taken this much only, you can easily find the area. So that I just consider that given. What is that? X square plus y square is equal to a square is that. What is the area formula? From a to b. X is equal to a to b. What is the a value? 0. What is the b value? A is that. Area under radius of the circle is a unit is that. Okay. Now I need the area is equal to integral of a to b. F of x into dx, or else we can write integral of a to b y into dx. We need the y value. So from the given curve, get the y value. What is that? Y square is equal to a square minus x square. Y is equal to plus or minus root of a square minus x square. I am not going to write the plus or minus because I just consider only in the first quadrant, so that I am just going to take, or better to write plus or minus root of a square minus x square. Now the required area is equal to. Now the required area is equal to 4 times of integral of a to b. A to b is nothing but what? A value is 0 is there. B value is how much? A unit is there. Because generally they are given. So 0 to a, A to b is over. Y into dx, y value is how much? Plus or minus is there. Leave it. Because I just consider the first quadrant value. Root of a square minus of x square into dx as it is. Because I just consider the vertical strips dx. If we can take the horizontal strips also, no problem. If you take in this manner horizontal strip, then it becomes a dy. So that is also I am just going to write one more value, or we can write integral of 4 times. If you consider this manner also, we will get the 4 times. 4 times of 0 to a only, because this is point also a. 0 to a. X into dy we have to write. What is the x value? X value is equal to root of a square minus of y square into dy. Either solve this one or solve this one. If you consider vertical strips, you have to use this formula. If you consider horizontal strips, you have to use this formula. Okay, better to take the dx because we are familiar with the dx. Anyway, and here one more formula we know that. What is the formula we know that? Integration of root of a square minus x square into dx. What is integration of root of a square minus x square? Actually, this is eliminated, removed from the particular syllabus. Formula derivation is there. I think derivation is not derived. A formula is mentioned. What is that? X by 2 into root of a square minus x square plus a by 2 into a square by a by 2 into sin inverse of x by a. This is the formula. This is a square by 2 into sin inverse of x by a. Yes, formula is correct. Are you clear? Now, so using this formula, we are going to solve this problem. Now, what we will get here? Replace it. 4 as it is integral of 0 to a. General formula is that just directly apply the formula. What will get formula? 4 into. Apply the formula. Same formula we have to write it. X by 2 into root of a square minus x square plus a square by 2 into sin inverse of x by a. Sin inverse of x by a. What a definite integral is that? What is the definite integral? From where to where? From 0 to a. Apply the definite integration is over for this one due to that formula. Now upper limit minus of lower limit. What is upper limit? 4 is product with all the terms. Upper limit is a. Wherever x is there, replace the a by 2. A square minus x value is a square. A square minus a square 0. This is 0 plus a square as it is by 2 as it is. Sin inverse of x is 1. X is a by a is 1. Sin inverse of 1. This is upper limit is over. Minus of lower limit. X value is 0. 0 into this number is 0 plus a square by 2. 0 by a is 0. So sin inverse of 0. What is the sin inverse of 0? Sin of how much is 0? 0. So this value is 0. The totally second term is 0. Next. I just continue here. 4 as it is. Now a by 2 into 0 is 0 plus a square by 2 is left. A square by 2. Sin inverse of 1 is nothing but pi by 2, 90 minus this whole term is 0. Log okay, complete. So what will get? 2 2s are 4, 4 get cancel. So pi a square square. What is the area under the curve or area enclosed by the circle? X square plus y square is equal to a square. Pi a square. Pi times of radius square. Pi times of radius square. That will get the required. I got the required result. Already you know the formula. What is the area of the circle? Area of the circle pi r square. You know that area of the circle is equal to pi r square. Do you know that? That one only we proved by using the integration. That's all. Nothing to worry. Okay. Therefore, the required area is equal to pi a square. Here r value is radius square. That's all. Very clear. Very simple. So whenever the total area is there, 4 times I just take it. Okay. Now, in the same manner, take the next example. Yes. Next one is find the area enclosed by the ellipse x square by a square plus y square by b square is equal to 1. Find the area enclosed by the curve x square by a square plus y square by b square is equal to 1. Sometimes they used to use the word ellipse and sometimes they used to do directly the equation. You should remember the curve. Already this is the ellipse. In the first PUC we have studied what is the shape of the ellipse, and there are two types, two orientations are there. X square by a square plus y square by b square is equal to 1. Major axis is along the x axis, and suppose the major axis is along the y axis. Y square by a square plus x square by b square is equal to 1. Major axis, minor axis, foci, like that. Eccentricity, length of the major axis, length of the minor axis, length of the lattice rectum. Several concepts you people have studied. Now here we need to find. I have already mentioned that first try to get the rough diagram. General form is that the ellipse is in this manner. So major axis is along the x axis, because here always A is greater than B. So here it is the origin. Center of the ellipse is at the origin. Now x square by a square. What is this point? This coordinate is a comma 0. This coordinate is 0 comma b. No need to take the explanation. Already everything is discussed in the first PUC. Okay, 0 comma b is this coordinate. This coordinate is a comma 0. Total area enclosed by the ellipse is required. Total area is required. Again the same thing, similar as a circle. I just going to find only this area. 4 times of this area will get the total area. Total area is required. So 4 times of this area will get the required total area. Therefore, the required area is equal to 4 times of integral of from where to where? From a to b. What is the a value? A value is 0. What is the b value? B value is a. Okay. A value is 0, B value is A is y into dx. We need the y value. Where is the y value? Resolve into this one. That will get y square by b square is equal to 1 minus x square by a square. LCM take a square minus x square divided by a square. Now we need the y square. Y square is equal to, can I write b square divided by a square? B square divided by a square into a square minus x square. Again, y is required. Y is equal to plus or minus b by a into root of a square minus x square. Are you clear? Very simple. Get the y is equal. That's all. Okay. Now replace plus or minus leave it, because I just consider the first quadrant 4 times of this area. That area will get it from this point to this point, a to b. That is 0 to a. 0 to a 4 times. Y value y into x. But write it 0 to a. What is the y value? Y value is b by a into root of a square minus of x square into dx. Just integrate. If you got this much, remaining thing is integration. You can easily do the integration. Nothing to worry. P and a are the constants. So take outside 4 times of b divided by a into a square minus x square under the square root. Formula is that, what is that? X by a, that is x by 2 into root of a square minus x square plus a square by 2 into sin inverse of x by a. Sin inverse of x by a. General form is the definite integral from 0 to a. Okay, apply the limit, simplify, we get the required result. So required area is equal to, required area is equal to 4 times, that the space is not enough. I just write here, required area is equal to 4 times of, so 4b is that 4b by a, 4 times of b divided by a. Now upper limit, what is the upper limit? Directly I just solve. If I replace the a value here, a square minus a square, x value is a, so a square 0, first term is 0, plus a square by 2 as it is. You can write directly a value, x value is a by a is 1, sin inverse of 1 is, that is nothing but 90 pi by 2. Next, upper limit is over, minus lower limit x value is 0, wherever x is there replace with 0, this is 0 whole term, plus sin inverse of 0 by any number is 0, sin inverse of 0 is 0, this whole term is 0. Now okay, complete, simplify. Therefore the required area is equal to how much? 4b by a into here a square or pi a square by 2 is 4 get cancel, one of the a get cancel, a b pi or pi ab. This is therefore the required area is equal to pi ab. Exactly square image. This is right the square image. So hence the area enclosed by the ellipse x square by x square plus y square by b square is equal to pi ab. So just remember this formula as a formula. If they ask in a 5 marks, you have to proceed all these things. And 1 marks question in competitive exam, CET exam, they will ask the directly find the area enclosed by the curve. Here generally question is that if they given x square by 9 plus y square by 4 is equal to 1. What is the area bounded by the ellipse? Pi ab, pi into a value is 3, b value is 2. 3 2s are 6 pi is the required area enclosed by the ellipse. This ellipse. Total area, not only this first quadrant value, total area, because I have already multiplied here 4 times of this portion. Okay, so this is how we have to get the problems. Okay, now I just stop here. The remaining problems will continue in the next video. Okay, so just remember this definition, how to apply, and integration is an application of integrals. Here main thing is formula. All the formulas, whatever the formula you have to remember, remember, or you know in your prescribed textbook, you must and should remember not only the integration, differentiation, integration, and as well as trigonometry. If you remember all the formulae, then you can easily solve the, or you can easily build the calculus. What is the calculus part? Calculus means differentiation, integration. In the differentiation, application of differentiation, several types of differentiation are there. Application of differentiation is there, integration is there, application of integrals is going on. Okay, these are all 4 chapters purely based on the formula. If you remember the formula, we can easily solve the any problem. So analysis is very important. What is the given problem? Due to that problem, what is the exact suitable formula we have to choose? That one you have to select it. Okay, so frequently I am just telling that make the formula list better, write in a quality paper, which is daily you have to see it, because this part is purely based on the formula. In the application of integral, only one formula is required. What is that one formula? That is the integration of root of a square minus x square. Except this formula, we are not using any other formula in the integrals. Is that clear? So just remember this formula and for the application of integral purpose. So other formula is required in the previously integrals. Okay, practice it. This calculus part comes and you are going to make perfect while practicing. Practice. Don't see blindly. This much. This we have to do. Okay. Don't see blindly. Must and should. You have to write letter to letter. You have to write letter to letter. If you did a mistake anything while substituting x value, upper limit minus lower limit, confusingly in the examination, first you are going to replace the lower limit, then we will get the negative value. Is that clear? The totally answer will be wrong. ನೀವು ಹೇಳಿದ್ರೆ ನೆಗೆಟಿವ್ ಅನ್ನು ಪಾಸಿಟಿವ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಮ ಇಲ್ಲ ಇದೇನೋ ಪ್ರಾಬ್ಲಮ್ ಕರೆಕ್ಟ್ ಆಗ್ಬೋದು, ಬಟ್ ಉಳಿದ ಕಡೆ ಅದಕ್ಕೆ ಭಾಳ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು. ಕರೆಕ್ಟಾಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರಿ. ಡೋಂಟ್ ವೇಸ್ಟ್ ದ ಟೈಮ್. ಓಕೆ, ಬಿಕಾಸ್ ಇನ್ ದಿಸ್ ಪ್ಯಾಂಡಮಿಕ್ ಸಿಚುವೇಶನ್ very critical position is there, so that reason exams are going to held it, nothing to worry. ಇದರ ಕ್ಲಾಸಸ್ ಮೇಲೆ ಇದ್ರ ಮೇಲೆ ಎಕ್ಸಾಮ್ ನಡೀತಾವ, ಗೌರ್ಮೆಂಟ್ ಇಂದ ರೂಲ್ಸ್ ಬರ್ತದ, ಅದಕ್ಕೋಸ್ಕರ ವೇಸ್ಟ್ ಮಾಡಕ್ಕೆ ಹೋಗಬೇಡ. ಟೈಮ್ ಎಷ್ಟಾಗುತ್ತೋ ಅಷ್ಟು ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೋಬೇಕು. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಸೊ ಐ ಜಸ್ಟ್ ಸ್ಟಾಪ್ ಹಿಯರ್. ರಿಮೈನಿಂಗ್ problems will continue in the next class. Thank you.